Please subscribe to the channel and make sure notifications are turned on.
Welcome to the Dev Banner. This is Eric. This week's how-to video is testing with Go and a little bit of the tools in Visual Studio Code. So why do we test? Well, we test functionality and if we ever change things over time, we can verify that our changes meet maybe some business requirements that we've set out for that functionality, or we need to change the tests so that they meet our new functionality. Either way, tests are pretty important, and I think it's something that everybody, as they write code, should think about and subscribe. Now, you can do test development beforehand, like, I'm gonna write my tests before, and then write your code, or you have an idea and you write your code, and then you go through and you write some tests afterwards to make sure that it still works and that you've hit all the use cases. Either way, I don't have an opinion on it. I normally write my code and then I write my tests to make sure that things are looking good, and it's really up to you. But I think the most important is writing good tests and making sure that your code is covered. And we'll talk about coverage here in a little bit, but I have some examples, and this is my little test tutorial project, and I made this utility folder, and in utility.go I have a couple of functions. I have this verify name. I have a couple of other just really simple comparison with arrays, and these are just some helper functions. We're not going to worry about those. But with Go, you would create a file called something underscore test.go. And in this case, I borrowed the name, I continued on the name of util. And that's, for me, that is like, if I have multiple files and I had multiple test files that went with those files in the same directory, then I knew which one was related to which. So I kind of follow this standard, this format. But one of the points with Go is that you make a underscore test.go file, and the Go testing tool will look for these files, and then we'll run the test for every function that starts with test. And there's also a benchmark, and we'll go over those here in a little bit. But the testing package from the people at Go provided this suite and functionality of testing. So as long as your function name starts with test and it's more or less says what you want to do, and it takes in a pointer to testing.t, then the testing tool will run this test. And so you'll see that this verify name, I have some business logic associated with it. Min has to have a min and a max length. The first character needs to start with a capital letter, and the last character needs to be number. So this is what I've done to fulfill these requirements, and if it's good, it'll come back as a true, and if it fails anywhere, it will come back as false. So you can look at those really quick, but it's pretty basic. Kind of like, does a password have an upper character and lower character and symbols and stuff like that. So that's kind of what I was basing it off. So I like to test to make sure that a true value will go through the system correctly. And so I'm just making it really plain that I want a true out of this function. And then I go ahead and run the function with the name. And I could have put this in here. I mean, it doesn't really matter. But then I check for what I came back versus what I want. And if it doesn't, then testing actually gives you an error. The errors like error F, error line, or just plain error, depending on what you want, kind of like the FMT package. And you print out what you expect. Why did it fail? Why did it fail this test? And you want this to be pretty, self-explanatory, so that when things do fail, that you can try to find it, look it up pretty quickly and see, okay, why that fell, and then go through the logic of your function and make sure that this unit test works correctly. So then I just created 4 more of each place where it would fail, which means I've gone down every path. And I think that's what's really important, is when you test, to make sure you go down each path. And the coverage will tell you if you've tested every path. And once again, I'll go over that here in a bit. So that means I need to test for every path, which means I need to test, in this case, if it's less than 4, did it go down here? And I want not valid, right? I want this is going to fail. So not only are you testing for successes, you're also testing for failures, and make sure that those failures are, behave like you want it to behave. And so that's what these 4 tests. So with that, what's really nice about Visual Studio is you can actually just run each individual test if you want to. So I'm gonna run this, and sure enough, it comes back and it says it's okay. Now, as you can see, it's running this tool go test. This one's putting a timeout, but this /run is actually just saying, hey, I'm going to run this test with this regex. So at the beginning of the string, it has to start with test, verified, name, success, and then that has to be the whole name. And that would only match this one. So, and then this is the package it's running. So, the Visual Studio tool is saying, hey, I just want to run it in this package, which is util. And I'll show you how to run it for everything here in a second. And so if you wanted to make it fail, then you would do the opposite, and you would, change this to false, and then run it again, and I'll show you what this guy looks like. And it wants false, got true, and how long it took, and then where it's at. This is okay. I'm going to show you an alternative package that I like to use for more display. But to go on, so save that back. So if you want to run everything, then we still do that go test. And all you have to do is say, I'm going to run it, and this is the package. But when you run this and you put //, you're going to say, hey, I want you to go and run recursively all the packages within this project from this location, is this project, and I want you to run all the tests. And so I'm just press enter, and it only found really one package, and it ran all these tests. I have more than just these 5s, but I just wanted to focus on these 5 for a second. So that's typically, if you're gonna like tell like your CI, like Circle CI, for instance, you can run your tests, and if there's any issues, then every time somebody checks in some code, then you'll know that you have some tests that are bad. This would be what you would put in the commands for it to run. So that is the testing tool, and it's pretty quick, and out of the box it's pretty simple. Just if you want to test all your tests in one go. Like I said, you can use the /run and run something like, run an individual test. And another thing that you can do with Visual Studio Code is you can actually debug, and it will compile and start the debugger and hit your breakpoint, which it did right there. It took a second to compile it, and you can basically do all the same things you would in the debugger, and that's pretty helpful. So one of the things that I wanted to show you is there's another, when you install Go and you install the tools, so I'm gonna come up to my palette and install these tools. One of the tools is generate unit test right here. And that is when you right click or control click in a Mac, this generate unit test for function option is there. And so I'm gonna go ahead and press that. And what that does is it gives me this message if it's done right. And so I'm come over utility test_test.go, and it created this template for me to start filling in. And this is pretty typical, that even though you're getting back, well, in this case, I am sending back a Boolean, but if you're sending back like an error or multiple, you'd have multiple return arguments that you want. But in this case, it just says I want this Boolean. And you put all these test cases here. And so what I wanted to show you is I did this earlier, and as you can see, I kind of started filling in, and they call this table testing, and I like it. I initially didn't like it, but I pretty much use this style versus this style, where it's one individual test. Why? Because it actually, you're going to save a little bit of space in the long run with this format. And so what I like to do is I like to fill in the first successful, and then when I need to test every branch, every condition, then I just go ahead and, go like, I say this is success and this is failed, and, minimum length. And so I come in here and I put this together, and so if we go ahead and run this, then it will run both of these tests, and if it failed, then it would tell you. Now here's the package I like to use, and you'll see that this is what they give you. They do some weird logic, and if it's an error, it gets a little bit more confusing, and there's nothing wrong with it. But I like to use this assert library, this stretcher R testify assert. And it just feels a lot like cleaner to saying, hey, if these two guys are not equal, then I'm going to assert. So I'm expecting these to be equal. And if they're not equal, then I'm going to give this value. Now, here's what's really nice and the first argument, by the way, is the testing.t argument, is the format of the error. So I'm going to change this to true and force it to assert. And I'm going to run this again. And it's going to come through and it's just going to say, you know, this is the print statement I had put in the actual code right here. And I should have put here on each one of those, because you can see that so let's run that again. Let's save it. Let's come back through. Let's run it again. So basically, it looks good. And even my print statement is not formatted very well. And so it says this is the string I gave it right here. And let's see. Oh, I actually have both cases in here. So the assert is this line right here. And as you can see, it gives you a little bit more information and it just formats it better. I just really like the assert. But the tool, the extra little tool, puts it in this format and uses this t.errorf. And you have to go and change it if you want to use assert. But I really like it. I really like this package. So that's testing. And now let's go into benchmarking. So benchmarks, so I'm going to come back to this guy right here, these two functions, because I'm going to benchmarks and they're a little different. They do the same thing, but they are different in how they go about it. One is a double loop, that's why I called it double. And one is this map where it makes a map and then it looks. And all this is doing is saying, hey, if there's integers in this compare that's not in the source, then I want a list of those, and that's what I'm returning is this diff. And so my tests are pretty close. This is it, right? So 2, 3, 4, 5. This is 1, 2, 3, 6, and 7. So I'm expecting a 6 and 7. So I'm gonna go ahead and run this. Looks great. That's what I'm expecting. Same as my map. I mean, it's basically the same code other than what functions it's calling. I'm gonna run that. Looks great. I wrote this test. I wrote the code, compared it. Everything looks great. So what the difference now is the benchmarks. And this is a benchmark test. And if you start it with a benchmark, then it wants at least this signature. And that is this for loop with what it's going to be calling. And what benchmark will do is it will run this so many times in a certain time frame, and it will see how long it takes to run each operation, and then give you kind of this average. And there's some more math to it, and if you want to read some more, go read. There's plenty of papers and blog articles about the insides of the benchmarking. But sufficient to say that we're going to run both of these. And so what I've done is I have these files of integers that I'm just going to load up from a file. This large source and large destination have I think the large destination has 100,000 integers in it. And we're going to benchmark it. And so you can actually, once again, come in here and you can say, I'm going to do this small. So I did do 2 smalls and 2 larges, one for each. And so I'm going to run this run benchmark through Visual Studio, and you can see that what it did is it told me to run nothing on the tests. It's an empty string with this regex, but with this slash or a hyphen bench, run this test. So we've seen this before, and as you can see that, which is the package, which is util. It also added this bench memory, which is this stat right here. So this small, which is like less than 20 for each one, it ran it 6.6 million times in 1.6 seconds, and it took 182 nanoseconds per operation, which means, so if you took, turn this into seconds, times it by that, you would probably get pretty close to that number. So it's pretty amazingly fast how it tests stuff. So let's look at the map diff. And so if we remember 6.6, and we run this one only had 1.8, and it took, instead of 182, 615. So this one actually is a little bit slower, well, a lot slower, I think. And it actually takes quite a bit of memory. Now, the reason I brought this up is I actually wrote this code, these array diffs, the other day at my job, and I thought the map was going to be faster instead of the double arrays. And it wasn't on my initial, as I'm showing you now. I'm like, wow, it's a lot slower. But as I got larger, I had a different outcome. And that's where this comes in. So we can go, and I am going to run, I'm going to copy and paste this guy. We're going to watch both of them small together so we can kind of compare, right? But when we do the large ones, something interesting happens. And that is the double only runs once, and see how long it took to run that. Now nanoseconds is what, to the 9th? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that one took like 1.2 seconds. Whereas the map, you got way less nanoseconds per operation, and it ran a whole bunch more. So benchmarking can help you. In this case, I found that with the larger numbers, my map, which I thought was going to be faster, was faster. So as you write your code and you're testing it, and if you want it to be more, if you want to know why, or if it's, operating fast enough for you, then you'll want to benchmark. And so there's ways to run, just like I've done here, right? This is just regex, and I'm telling it not to run any of the tests, just the benchmarks. And you just need something as simple as that. This -v, I think, prints all this out for you, just your specs on what it's running on. And so that's benchmarking. And so the last thing I wanted to talk about is code coverage. And code coverage basically is another part of the testing tool, an option that will help you figure out which code, which paths in the code are being tested for. And so you would run something like this. And once again, I'm going to do the //. I'm going to add this cover profile, and this right here is saying where it's going to output the results of this. So I'm going to go ahead and press cover or press enter. Okay, so off the bat it says, hey, 83.8 of all the statements is code coverage, and that's actually pretty good. But you're like, well, that doesn't tell me, like, if I have multiple packages in this project, and which ones do I really want to look at. So what they've done is they've given you another tool called GoTool, and GoTool has a bunch of different actual tools that it will do, but one of them is called cover, and you give it a parameter, an argument of -HTML, and you point it to the file that you just made. And here's the file we just made. And basically it just goes through line by line in each package where it starts and where it ends, meaning that this is the path that it started and where it ended. And the first number is how many times it went through, and the second one is did it have a test or not. So the coverage actually goes out and puts insert statements into each of the path branches, and then runs the tests, and then it came across it or didn't come across it, then it marks it, in this column. And then they use both of those numbers to figure out what the percentage is. So then this thing will take this result and it will make you an HTML page. And that went to a different window. And then you'll get this drop down of each file in each package and its percentage. And you can, since I only have one, there's only one option. And then as you see, not tracked versus not covered versus covered. And you'll see that these two I didn't put tests on it because I don't really care. They were just kind of helper functions. And so that's kind of the tool they giving you out of the box to look at coverage. Now, what I wanted to show you is another really cool in Visual Studio that will show you the same thing but on the fly. So I'm going to press Shift Command P and get the palette, and I'm going to look for this Go Toggle Test Coverage Packages, and I actually bound it to Option Command G. And so if I press that, or if I toggle it through the command palette, then I get the same kind of highlighted as that website. If you come into here, the reds are there. So another cool tool in Visual Studio Code for you to use that will help you with your code coverage. And I hope you learned something. See you next time.
Please subscribe to the channel and make sure notifications are turned on.